Okay. In previous class, we covered until this part. Okay, I better write down something. In previous class, we discussed about this part, customer requirement in customer's own voice, and this part, product characteristic. Okay, sorry, this should be right. Okay, and their correlation and the initial assessment here. Okay, let's look at the handout. It was the brief handwriting of this QFD analysis. So the customer requirement is exactly same I covered in previous class, and the product characteristics are also same. And customers' weight could be different, but it is just numerical assignment. 1 is least important, 5 is most important. So according to this handout, holds a lot have the 4 weight, 5 keeps drink warm is 5 of importance. Okay, and current rating means the evaluation of the current design, which means in order to have this QFD approach, you have to have a little bit concrete idea. What's going to be your cup? Is there any other alternative or something like that? So current rating, you have your own design, and you can evaluate your current design with respect to this customer requirement. And this is the second column here. So holds a lot, well, my design now has the point of 3 in terms of holds a lot requirement. And my design has number 2, score of 2 in terms of looks good customer requirement. And next one is option A rating and option B rating columns. I'm talking about this column. Well, it is not set number A or number B, but anyway, if you have the n number of design alternative, you're going to have n different and additional columns here. Okay, so this situation assumes that you have major design and second and third design alternative, which is A option and B option. Okay, it could be different if you're comparing your own design with competitors' design. Like there are competitor A and there are competitor B, then you can also compare your design with competitor's design, like this. So by this comparison, you also then can make your own target. Well, by close comparison of my current design with competitor A and B or other design alternative, now you can make your own target. I'm going to achieve this target by this team discussion. Okay? Well, at least compared to other things, I have to improve my own design. For example, currently holds a lot customer requirement. My rating is now 3, but I will increase it to 4, something like that. Okay? The next column is improvement ratio. It's just a simple arithmetic. It's 4 over 3. Your target divided by current rating. So for holds a lot customer requirement, your target is number 4, but your current rating is number 3. 4 over 3 is 1.3. The keeps drink warm customer requirement, your target is 5, but your current rating is 4. So 5 over 4 is equal to 1.2. Any questions so far? Okay. Next one. So improvement ratio means how much do you need to improve your current design? Okay. So there is stay where put the 4th row of the customer requirement. The target rating is 5, but your current rating is 2. So 5 over 2 means 2.5. So in that customer requirement category, you need a lot of improvement. Okay? Okay. The key or sales point is a little confusing. Okay? The bottom line is you have this much of the customer requirement. What is your key sales point, key point to appeal your product per customer? Let's assume you're going to make a commercial film on to be aired or something like that, or if you to make a product brochure or advertisement, what's your point to appeal to the customer? That has very high correlation with customer requirement, but customer requirement or the relative weight or something, but it is not that simple. Okay? So according to this handout, the most important thing is 1.5 stable and 1.5 looks good. So we are going to make a product advertisement emphasizing this is stable and looks good product, something like that. So the scale is from 1 to 1.5, but it is not that high differentiation, but you need those kind of things. Okay, any questions so far? Yep. What? Sales point? Sales point? Okay. Sales point. It's a little bit extension of what I was talking about, Sonata or iPod or MP3 player or something. You got to hit the right spot, what the customer wants. Okay? That is the this sales point indicates those kind of information. Okay? For example, there is a Sonata. It's a 4-door sedan, very popular in Korea. And it has many, it will have many customer requirements, like economic value, engine power, speed, or something. But if you look into your Sonata, have you ever watched the TV about commercial film on Sonata? It does not list all these customers' requirement because it's too long and you may lose your focus. So they just categorize some of the customer requirement and choose the 1 or 2 or 3 most important thing to appeal to the customer, and they focus on those characteristics of customer requirement. Okay? Yeah. What is that? I don't know, brand or something. Those information will be listed on key or sales column here. Okay? Okay. Next column is absolute weight. It is just another simple arithmetic calculation. Absolute weight can be calculated by customer weight times improvement ratio times sales point. Okay, once again. I think this chalk is really, really expensive. How come this? Well, absolute weight of the is the just product of customer weight, improvement ratio, sales point. So, customer, let's discuss about this. If the customer weighs something very heavily, then it will have heavy absolute weight. If the improvement ratio is high, which means we need a lot of room to improve, then absolute weight is high. Anyone wanted to explain this phenomenon? Is this just straightforward? Why we are not focused on the smaller value of improvement ratio? Because which means if the improvement ratio is very low, then we already achieved the goal. Okay? If we already achieved the goal, then we don't have to consider it too much, right? Because we are already there. So that's why higher improvement ratio, higher absolute weight. Sales point, that is straightforward. If the higher sales point, higher absolute weight. So it is just straightforward. You can utilize Microsoft Excel or something like that to automatically calculate this absolute weight of each of these customer requirement, right? And once you calculated absolute weight, relative weight can be also easily calculated. It's a percent of absolute weight. So relative weight is summation of all the absolute weight of customer divided by summation of all the absolute weight divided and current absolute weight. Because we are dealing about the percent value, you can easily multiply 100 to get this relative weight of each of the customer requirement. Okay? Straightforward. The last column is ranking. It's just a ranking of your relative weight. So, in your handout, the highest relative weight is 20.1. The last row, easy to hold, customer requirement. So that has number 1 ranking. The second one is 17, stable, right? And the like. You can easily also, utilizing your Microsoft Excel, you can have all your own rankings like that. Okay. At this point, now you have what's the most important customer requirement and the like with qualitative ranking and quantitative information. You have the relative weight. Okay. Questions so far? Okay. Now it's tackle down this part. You need lots of team discussion to fill out this matrix. It's a relative matrix. There is some product characteristic and some customer requirement, and well, you can utilize your own scaling system like a 1 to 9 or triangular circle, double circle, or something like that. In my example, I assigned this scaling system with this value. Strong relationship, moderate relationship, weak relationship, and the like. So, for example, holds a lot. Does it have some relationship with height? Yes. So I put that one. Bottom area? Yes. Handle size? No. So I leave it blank. Color, durability? No relationship. Volume? Very strong. And the like. Right? You can fill out this kind of information with team discussion. Okay? Next step is to calculate this part. First one is also calculating absolute weight. The formula to calculate this absolute weight is multiplying the relative weights calculated here with this one. Okay? For example, there is a volume product characteristic here in the middle of these columns. It has very strong relationship, so 9. And following down this column, there is another one, looks good. And nothing else. Right? How can I calculate the absolute weight here is, if I follow this one, there is the holds a lot characteristic has the relative weight of 8.3, and looks good is the relative weight is 6.0. The formula to calculate this one is 9 times 8.3 plus 1 times 6.0. Summation value will be not 81. That's how you calculate the absolute weight of each of your product characteristic. Okay? Question? Once you calculate your absolute weight, it's another very straightforward arithmetic. Based on this absolute weight, you can easily calculate the relative weight. First one, sum up all the absolute weight, okay, like same formula. Absolute weight and your current absolute weight. That is your relative weight. And once you calculated your relative weight, you can also easily calculate the ranking. So for our specific example, height of center of gravity has the highest ranking. The second one is the weight. Third one is bottom area and the like. And the other things are just another information. Unit of measure. What's the unit to measure your customer characteristic? For example, height. It will be measured in millimeters. Bottom area, square millimeters, and the like. Current value. Based on all this one, and now you have your own design or competitor's design, you can write down the exact values of your current design. Okay? 89 millimeters or something like that. Option A value, option B value. It's exactly same as the option A, option B here. If you have another design alternative like this, write down the value of that. Or if you have the competitor A design, competitor B design, you can also write down here. And based on close observation with option A and B and your current design, you can also derive your target value. What's going to be our design? Once you have this target value, then your design process is complete. So, based on all this handout QFD process, among many designs of this captain's cup, the design I choose looks like that. It has covers and seat hole. Okay, large handles. This shape will ensure your volumes, higher bottom area and lower center of gravity. And some rubber-like material at the bottom to increase the friction coefficient. And all these cups are insulated. Okay? Question? That's just one example of QFD. This is a very, very simple design process. It's a designing a cup, right? So it is this much simple. But if you're designing offshore wind turbine system, it is very complex system. Can you do it in one QFD? Well, maybe not. So something to consider is, for example, in some of the literatures, because this is a customer requirement, okay? But customer requirement is like tree. Even though this is a one simple customer requirement, if you think over and over, you can divide that specific customer requirement into more detailed customer requirement. Okay? Same thing happens here. Product characteristic. It's also some characteristic, but however, if you think over and over again, it is always possible to divide one specific customer characteristic, product characteristic into more detailed one. Okay? So here you have another tree structure. Point is, you got to choose appropriate level of detail. And you got to match those level of detail here and here. For example, if you choose this level, very high level, and if you choose very high level for the customer requirement, but very detailed level of product characteristic, well, it will not work well. So, higher level, then choose higher level here. If you choose a detailed level here, you choose the detailed level here. Match the level of details here and there. Okay? And by cleverly choosing the right level of detail, you can manage to build this quality of house of quality. Okay? Question. It works well in most of the cases, but sometimes it doesn't. What if you see a empty row here, no nothing here, then what's the problem? Your customer requirement doesn't have any relationship with all of your product characteristics. What's the reason and what you're gonna do? Anyone? Come up? Idea? Yep. It's even if this is a very important, I mean the right customer requirement, but nothing is related to your product characteristic, then your list of product characteristics is not complete. Have to think more about this building of product characteristic. What about the other side? You have some product characteristic listed here, but it has nothing to do with any of this customer requirement. Exactly. That's a useless product characteristic or too much detail. You just eliminate the product characteristic, or you can adjust the level of detail. Okay. What if one product customer requirement has every relationship is important? What if this customer requirement has all the relationship with all the product characteristics? It's darn important? Yeah, but you need more details. You need more breakdown of that specific customer requirement. Same thing happens here. Okay? What if everything is diagonal about this matrix? Nothing there, but looks like that. 0 and 0. This is very nice shape in axiomatic design, but what's the reason for this product characteristic? It will not give any more information. Okay? The reason for that is you're just in your mind, your customer requirement and product characteristic is not clearly defined and separated. You're thinking same way. So your thinking is volume is important. So it's just changing a word. Like you said volume here and holds a lot here, and you said tall here and height here or something like that. Okay? You're just utilizing same information here and there. That is the reason for this diagonal matrix. Okay. Another question. Have you read the handout about the QFD, the House of Quality? Okay. Any discussion or question about that material? Okay, that is the D standard first step write-up, and very nice reference to learn about the QFD. So that is the kind of keepers. Okay, let's close our discussion about this QFD here, and let's resume to our approaches from view from general design to AHP. It stands for Analytic Hierarchy Process. Sorry, I sent out the lecture note this morning around 9:30 or 10. So have you checked your email? No, not yet? Okay, sorry. I will try to send out the lecture note one day before. Okay. AHP. It is developed by Sati. If you search the KAIST library with this AHP, analytic market process, you will find a book written by Sati. That's the original book written by Sati, and actually this AHP is kind of invented by him, and it is written through many research papers written by him, and this book is kind of a summary of those previous research papers by himself. Okay, this is a rational method for prioritizing alternatives or constructing a consensus using experts pairwise comparison. Okay, keyword, rational method for based on pairwise this idea was originated from the observation. Humans are very good at comparing. Okay, think about yourself. If you're going to purchase something, microwave? Okay, if you're going to purchase a microwave, you need one, and you went to the Home Plus, and there is a microwave section. Okay, if you have only two options, there is a brand A microwave and brand B microwave, you can easily pick one. Okay, what about you have three choices? Well, not bad. How about 4? Selection time will be increased, but no problem. How about 6 and 7? Well, it's an observation from psychology. Humans are not very good selecting options if the number of options is larger than 7. Okay? But in design process of the complex features, you sometimes have to choose some out of 12 or 100 or 1,000 of different options. Okay? For example, cups. We are designing a cup. If I ask you, hand out a blank sheet of paper and draw your own concept design of cup, then we will have maybe everyone have different design, and if we got to choose one out of this 17 people's design. 17 people, 17 design. Everyone will have their own design or something like that. So it's like a very complex. But we have some method to do this one. For example, even though we have only two choices, product A and B, but if the category to compare these A and B are hundreds, okay? For example, you're purchasing a 4-door sedan, and there are 3 or 4 out there in Korean market with same price range. But product characteristic of a 4-door sedan is like it could be easily 100,000 or something, right? Okay? How can you prioritizing those options? Engine size, price, airbag, or something like that. It is not that easy to directly rank the most important characteristic of your product out of 100 or something, but you can easily rank pairwise comparison. Very, very traditional example of this HHP-like thing is, have you ever heard about 이상형 World Cup? Right? It is like that. There is some 32 number is about 32 or 64. All female entertainer or TV talents, singers or actress or something like that. And it is really, really darn hard to just watch your dream girl out of this 32 or 64. But if you compare 2 by 2, then you can easily choose your dream girl out of it. People are very good at pairwise comparison, really. But if the number of choices is increasing, that you will be at loss. Well, we have some method to helping you. Okay? Okay. This is AHP. We have only 15 minutes left. Okay. Okay, the thing is like that. First one is, you have to put the value pairwise, and then based on that one, build a matrix. For example, if you have 3 options, A and B and C, and it is for the illustration purpose, let's assume that it's really, really hard for us to choose one best option out of 3, because 3 is a too large number. But we can do A-B comparison, A-C comparison, and B-C comparison. Okay? Okay. The idea is make this kind of scale. If A and B are equally important or preferred, assign value of 1. Okay? If A is weakly more important than B, assign 3. Weakly, I don't know. If A is more important or preferred to B, 5. If A is strongly more important than B, 7. If A is absolutely more important than B, assign value of 9. Okay? So the idea is, have to do this comparison. A and B, compare it. AC, compare it. BC, compare it. The other way around. And the important characteristic of this AHP is, what will happen if you change this one? If A is strongly more important than B, A will have 5 over B. What's the value of the B over A? It will be reciprocal value. So if A has value of the 6, A has value of 5 over B, then B will have the value of A, value of 1 over 5 over A. So we are comparing A to A. Based on that skill, all the diagonal term will be 1. Right? It's exactly the same one. A compared to B? Well, let's assume it. Based on that one, A is a little bit important than B. Okay? Then it will be 1 over 2. Okay? Assume that A is really, really important, so it has the scale of 6. Then this one will be 1 over 6. Let's assume that B is more important than C, this much. Then it will be like that. Okay? Any question building this matrix? Okay. There is a one thing to consider, because we are just comparing two things, right? But something is happening here. For example, if A is about 2 times important than B, and if B is about 3 times important than C, right? It is kind of logic. We can easily say A is about 2 times 3, which is 6 times important than C, right? Right? We cleverly did that by putting 60 here and 1 over 6 here. But this is not always the case. For example, let's assume that you are comparing a 100 by 100 matrix, and our logic will easily fail to get this number 6. Sometimes it is not. Sometimes it's a contradicting. So, for example, we are just comparing A is 2 times important than B is 3 times important than C, but all of a sudden, well, C is 5 times important than C, or BA, or something like that. Those kind of result could come because we are only human. Okay? But if those kind of contradicting information comes into this matrix, then this AHP will not correctly work. Okay? So before keep going on based on this matrix, we need to check if this matrix is logically consistent. That is, it's another keyword in AHP, cardinal consistency index. Okay, if we calculate this cardinal consistency index based on this matrix, and if it passed this test, then we can conclude that, well, even though if we constructed this matrix by only 2 by 2 comparison, then all this information is logically consistent. Okay? Let's go to the calculation of the cardinal consistency index. But however, before doing that, we need to consider about the matrix itself. Okay, question. Can you calculate eigenvalue of a matrix? Any problem in calculating eigenvalue, lambda, of square matrix? Okay. Assumes that everybody's familiar with eigenvalue calculation. Let me ask a couple more questions. This one, all the element is positive value, no minus, no zero, because it will be a number from 1 to 9, or reciprocal value of this 1 to 9. Every element is positive. Okay, then is there any characteristic of this matrix, all positive? Or we call this positive, am I right? Reciprocal matrix. Okay, another question. If you guys are not participating in this discussion, I'm gonna keep asking the question. What's the rank of this matrix? Or what's the order of this matrix? Okay, this is 3 by 3 matrix, and how many eigenvalue can you get by eigenvalue analysis? This is 3 by 3. 1. Why? Why? How many eigenvalue can you calculate from 3 by 3 matrix? Okay. 3 maybe, right? Yeah.
According to your property of the positive this proper matrix, the minimum, the maximum minimum is order of matrix.
Right. Yep. So maximum eigenvalue, I would write lambda sub max is always equal to or greater than n, which is order of matrix. So it is not the number of eigenvalue. However, there could be many eigenvalue based on this order of this 3 by 3. For example, 3 by 3, if it is autonomous or satisfy all these nice requirements, then it will have the 3 different eigenvalues because it's a 3 by 3. If we are dealing with a 5 by 5 matrix, and if those matrix satisfies all these nice conditions, it will have 5 eigenvalues, right? Okay, but once you calculate the eigenvalues, you can rank it by this value. So the largest eigenvalue is lambda max, and the smallest one is lambda min. Or eigenvalues could be same to each other, right? Okay. Yep. So that is the one thing we need to calculate, this consistency index, which is defined as lambda max minus n divided by n minus 1. Okay? Okay. So that's all for today's class, and we will talk about this AHP in Wednesday's class a little bit more. and we will talk about the axiomatic design on Wednesdays. Sorry for the short class today, but I sent a lecture note this morning as well as some paper, research paper. I don't remember the exact name, but the paper's contents is they are utilizing this AHP to compare the competitiveness of Eastern Asian ports, China, Japan, and Korea. And in order to choose or compare their competitiveness, they got to know which is the most important characteristic of a port, container port or something like that. They utilize this AHP. So please read all the lecture note as well as this research paper, reading material I sent this morning. If you haven't got the email because you're enrolled later, ask TA about this material. Okay. Thank you.